Okay, so this is the next example I want to discuss. Again, we have three variables and you have to solve this system. So notice that this is not in a triangular form. We have all three variables in all three equations, which means we need to reduce this into a triangular form. Since we have all the three variables in all three equations, we might have to follow all these steps given in this process. So let's start with step number 1. So if necessary, you have to interchange two equations, or you can use multiplication to make the coefficient of x in the first equation as 1. So bottom line, the equation in the first row, the first equation, the coefficient of x should be equals to 1. Okay, so if I go back to my other equation, I see a equation with the coefficient of x as 1. So the easiest way would be to interchange these two equations. So if you interchange these two equations, the first equation will have a coefficient of x with 1. So I'm going to interchange the first equation and the second equation. So if you interchange that, your new system becomes this. This is my first equation now. The second equation is this. And third equation, it's going to stay as it is. Z equals 9. So this is my new set of equation that I wish to solve. So let me copy this. Great. Okay, so now let's move into the second step. So you have to add a multiple of the first equation to each of the following equation, so that the coefficient of x in the second equation and the third equation becomes 0. So that means you have to get rid of x variable in the second and third equation. Okay, so to do that, you have to add these equations separately with the first equation but with a multiplier, and somehow you need to get rid of this x variable. To do that, let's start with trying to get rid of x value in the second equation. So you need to do that with first equation. So what I'm going to do is, in order to get rid of this positive 2, I'm going to multiply the first equation by negative 2, and I'm going to add it into the second equation. Okay, so let me write the simplification. Okay, this is what I'm going to do. I'm going to multiply first equation by negative 2. So negative 2 is because here I have a positive 2. So to make this disappear, I'm going to use a negative 2. And you have to add this into the second equation. And the resulting equation will be replaced the second equation. So if you multiply x by negative 2, you get 2x, and then positive 2y minus 4z equals negative 2 multiplied by negative 3, a positive 6. And you add that into the second equation. The second equation is this. Okay, let's do the simplification. So these terms will cancel out. So you have only these 4 terms. So you have to add positive 2y into negative 3y, which will give you a negative y. And if you try to simplify these alike terms, this will give you a negative 3z, and 6 negative 1 is 5. So now this is the resulting equation. So you can replace this resulting equation with equation number 2. Okay, so let me rewrite my new system. So I'm going to paste this system, and instead of the second equation, I'm going to erase the second equation, and I'm going to write my new system, which is this. Okay, here we are. Okay, so now I have to do the same simplification with the third equation. So the second equation over here, we don't have a x variable. Now we have to get rid of x variable in the third equation as well. To do that, I'm going to use the first equation. Here we have a positive 3. To get rid of that positive 3, I'm going to multiply the first equation by negative 3. You have to multiply the first equation by negative 3 and you have to add it into the third equation and you have to replace third equation by the resulting equation. So if you multiply first equation by negative 3, you'll get 3x plus 3y minus 6z equals negative 3 multiplied by negative 3, a positive 9. And you write your third equation, which is this, and you add them together. So if you add these together, these two will cancel out. So here, these are alike terms. If you add, you'll get 4y, and this is going to be 7z, and on this side, you'll have a 18. Okay, so now your system gonna update with this equation. So I'm going to paste this like this, but the third equation you have to change as 4y minus 7z equals 18. So this is your new system. Okay, this system is much better. It's one step closer to that triangular form. It's because the second equation is with two variables, but still we do have two variables in the third equation. So somehow we need to make the coefficient of y here a 0. Okay, so let's move into the steps. So here let's move into the third step. In the third step, you are asked to multiply both sides of the second equation by a number that make the coefficient in the second equation equals to 1. So now before we move ahead, you have to make sure the coefficient of y is equals to 1. So here this is not equals to 1, it is equals to negative 1. So what you can do is you can take this equation, the second equation, and you can multiply it by negative 1. So you can do all these calculation. It's because these are equations. But make sure whatever you do to one side of equation, you have to do it for the other side as well. So now what I'm going to do is I'm going to take the second equation and I'm going to multiply it by negative 1. Okay, I'm going to copy this down. So because that will save some time for me. And I'm going to paste it. And I have to multiply the second equation by a negative 1. So if you multiply this by negative 1, you'll get a positive y. So I can erase this. And this is going to be a positive 3z. And this is going to be a negative 5. So this is my new system. Okay, moving forward. Next step. So now add a multiply for the new second equation to the new third equation so that the coefficient of y in the newest third equation becomes 0. Okay, so that means somehow we have to make the coefficient of y equals 0 in the third equation. To do that, we'll be using the second equation. And since here we have a positive 4, I'm going to multiply the second equation by a negative 4 and add it into the third equation. So let me write the notation. So I'm going to take my second equation and I'm going to multiply it by negative 4 and I'm going to add it into the third equation and I'm going to replace the resulting equation for the third equation. Okay, so let's do the simplification. So take this equation and you have to multiply each term by negative 4. So in that case, you'll get negative 4y, negative 12z equals positive 20. And I'm going to write my third equation, which is 18, and I'm going to add them together. So if you add them together, here you'll have 19z equals 38. So now let's take my system and I'm going to replace my new system with the third newest equation. Okay, so this is my new system, but the third equation is going to replace by 19. Okay, I'm going to use a different color. 19z equals 38. So this is my new system. So now this is in triangular form. It's because the first equation we have only z variable, and over here we have only two variables, and the first we have the three variables. So now we can solve this very quickly. Let's take the third equation. The third equation says 19z equals 38. To isolate z on one side, I'm going to divide both sides by 19, negative 19. Then you'll get z equals negative 2. Okay, moving forward, to evaluate y, I'm going to use my second equation, which is this. So y 3 multiplied by z is negative 2, it's going to be negative 6, equals negative 5. So y is going to be a positive 1. The first equation, x negative y. Negative y is 1. And then this is going to be a negative 4 equals negative 3. This is a negative. So x negative 5 equals negative 3, x is equals to 2. So the solution for this system of equation is equals to x equals 2, y equals 1, and z equals negative 2. So let's try another example. So here again, this example we have to solve for three variables, and this is not in triangular form. And let's follow the steps. The steps are, you have to make sure the first equation with x variable with coefficient 1, here we don't have, but the third equation, it does have a 1 as a coefficient for x. So I'm going to interchange 1 and the third equation. So in that case, you'll get x plus 2y negative 3z equals 0. And the second equation, I'm going to write that as it is. 4y minus 5z equals negative 14. And the third equation is going to be 3x negative 4y plus 6z equals 10. Okay, I'm going to copy this down. Okay, so now what you have to do is you have to eliminate x variable in the second and third equation. To do that, what you have to do is you have to multiply the first equation by a multiplier that makes this positive 2 disappear. To do that, you have to multiply the first equation by negative 2. So you have to multiply the first equation by negative 2, and you have to add it into 2, and you have to replace the second equation. So if you do that, you'll get negative 2x negative 4y plus 6z equals 0. And the second equation is 2x minus 4y minus 5z equals negative 14. So if you add them together, you'll get negative 8y plus z equals negative 14. So this is your resulting equation. You have to replace your third equation by this the second equation by this resulting equation. So let me replace this here, and I'm going to use the second equation. I'm going to update my second equation by negative 8y plus z equals negative 14. Okay, we don't have an x variable over here. So you have to do a similar process for the third equation as well. So to eliminate x from third equation, you have to multiply the first equation by negative 3, and you have to add it into equation 3, and you have to replace equation number 3. So the steps are, it's negative 3x negative 6y plus 9z equals 0, 3x 4y plus 6z equals 10. Okay, it seems like I use a different color. So let's try to, okay, this is good. And over here, this should be in red. Okay, this is good. So now let's do the simplification. Here you'll get 10y plus 15z equals 10. So now let's replace this system with my new equation. So here the third equation, it's going to be replaced by 10 negative 10y plus 15z equals 10. Okay, so now it's much better. We have two variables in the second and third equation. So now we have to make sure the first, in the second equation, the coefficient of y is 1, but here we have a negative 8. So to get rid of this negative 8, what I'm going to do is I'm going to multiply the second equation by negative 1 over 8. Yes, so let's multiply the negative 1, the second equation by negative 1 over 8, which means you have to multiply each term in the second equation by negative 1 over 8. Okay, copy this down and you paste it over here. And if you multiply negative 8y by negative 1 over 8, here you'll get a positive y. And for the second term, it's going to be like a negative z over 8. And over here, it's 14 over 8. So this is the system. Okay, so now you have to get rid of this 10y. I mean, you have to get rid of this y variable in this equation. To do that, you have to multiply the second equation by a positive 10, because you have a negative 10 here. To get rid of that, you have a positive 10. So you have to multiply the second equation by 10 and you have to add it into 3 and you have to replace it with equation 3. So if you do the simplification, you will get here 10y minus 10 over 8z, 140 over 8. And the third equation is negative 10y plus 15z equals 10. And if you do the simplification, you'll get like 110 over 8z equals 220 over 8. So now you can replace your third equation by this. So let's copy this down and let me paste that over here. And I'm going to copy this down. The third equation, it's going to be 110 divided by 8, z equals 220 over 8. So now you have to solve this system of equation, and this is in triangular form. You don't have to do any you don't have to do any other reformulation. It just you have to use these three equations to solve these variables. Okay, so let me take a new page and let me paste my triangular form and let's solve this quickly. So the third equation gives 1 over 10 over 8 z equals 220 over 8. To solve this, you have to multiply both sides by 8 over 110. In that case, you'll get z equals 2. Okay, moving on, to get the value of y, I'm going to use my second equation, which is this. So I'm going to substitute the values. So here you'll get 2 over 8 and this is 14 over 8. The value of y will be given 14 over 8 minus 2 over 8. Okay, so here you have to add these two values. It's going to be 16 over 8, which means y is equals to 2. So these are the values. And to get x values, you have to use the first equation. This is my first equation. So 3x is equals to, okay, so I think this is not my first equation. I changed my first equation. So the first equation is x plus 2y minus 3z equals 0. So x plus 2, the value of y is 2, which is 4, and z is 2 again, so it's going to be 6 equals 0. So x is 2. The solution for this system is x equals 2, y equals 2, and z equals 2.